Imagine soaring through the empty space at speeds of over 137,000 miles per hour. A speed so blistering enough to cover the Earth more than once in an hour. Now imagine this. You are not from this area. You've journeyed from the distant reaches of another star system, carrying ice and dust-etched secrets from time before our sun even ignited. That's the background of 3ATLAS, the third confirmed interstellar comet to graze our solar system, discovered by the sharp-eyed in July of this year Chile's Atlas Survey telescope. It streaks toward the sun's brush closest to it on October 29th. Scientists discovered the sun worldwide are racing against the clock to unravel its enigmas. Why is this cosmic wanderer so special? Why does it challenge everything we know about comets and the building blocks of worlds? And could it hold clues to the universe's most fundamental inquiries, like how planets form or whether we're truly alone? Buckle up, space fans! Today, we're diving deep into the extraordinary tale of 3Atlas, a visitor who is altering the regulations of interstellar exploration. Let's begin at the beginning because every great space story has one, and this one has its roots in the ingenuity of human curiosity. The Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, is the first line of defense against cosmic surprises. Operated by the organization and funded by the University of Hawaii, its telescopes scan the skies nightly, hunting for objects close to Earth that may one day pose a threat. One of them, on July 1st, 2025, those telescopes in Chile's Rio Hurtado spotted a fuzzy dot and a faint streak moving in the direction of the starfield Sagittarius constellation. At first glance, it appeared to be another possible comet. But as data poured in from archives dating back to pulled from Atlas stations on June 14th globally, including Caltech's Wiki Transient facility, astronomers discovered this was no ordinary rock. Its course was to straight, its speed to relentless, with an orbital eccentricity exceeding 6 ellipses that go far beyond the bounds of solar system comets. 3.1. ATLAS was officially dubbed the third interstellar interloper, following the enigmatic cigar-shaped Oumuamua in 2017 and the more comet-like Borisov in 2019. What does interstellar even mean in this context? Consider our solar system to be a pulsating neighborhood with the sun at its center and planets, asteroids, and comets orbiting as if they were regulars. However, interstellar objects are tourists from other communities, ejected from distant stars billions of years ago, drifting through the galaxy until gravity snags them into a brief flyby. We were baffled by Oumuamua as a hint of non-gravitational acceleration at invisible outgassing or something stranger. Borisov was a relic frozen in time, belching familiar comet chemistry like hydrogen cyanide. But 3ATLAS, it's arriving with a resume that demands a double take. Discovered at about 410 million miles from the Sun, Jupiter is already quite a distance away, releasing its icy exterior and entering a coma, a hazy envelope of gas and dust that makes it glow like a lantern from the heavens. NASA's Hubble Space Telescope caught a stunning snapshot on July 21st, revealing a teardrop-shaped dust cocoon surrounding its core with stars in the background streaking like cosmic contrails because Hubble was tracking the comet's hyperbolic sprint. To comprehend why we are drawn to this comet, we need to zoom out to the bigger picture of how these wanderers form. Our own solar system's comets hail from the Oort cloud, a spherical shell of icy debris left over from the sun's birth 4.6 billion years ago. Picture the chaotic early solar system demolition derby. Swirling dust and gas clumping into a protoplanetary disk, planetesimals that eventually birthed planets. Some of the leftovers were flung outward by gravitational tussles with migrating giants like Jupiter. However, interstellar comets tell stories from other disks around other stars, possibly from the beginning of the galaxy, when the universe was just a toddler at 7 billion to 14 billion years old, as per a July 2025 study led by Matthew Hopkins. That study, drawing on the comet's high vertical speed in comparison to nearby stars, suggests three ATLAS hails from the Milky Way's thick disk, a region of ancient metal-poor stars. If true, this comet is a time capsule older by billions of years than our solar system, whispering about conditions in a younger, more wild universe. Let's go now right down to the core of what makes 3I Atlas a headliner, its sheer scale and the puzzles it poses about mass and structure. Early estimates from Hubble pegged the nucleus, the solid icy core, between 1.4 and 3.5 miles across, roughly the size of a small mountain. However, as observations refined, that lower bound got in the way, with some models suggesting a diameter closer to 5 kilometers or more. Why is size important? Because everything is driven by mass orbital mechanics. A preprint from July 2025 from the AVLO at Harvard and their associates speculated on an anomalous heft based on estimates of more than 33 billion tons, the comet's apparent resistance to releasing forces. The analogy is as follows. Imagine a sailboat puffing wind from its sails like a comet expelling gas jets. Normally, that thrust nudges the boat off course. Yet ATLAS's path remains stubbornly straight, as if because of its enormous mass, solar heating barely registers. Always the provocateur, it floated a 30 to 40% chance this defies the laws of nature. But let's adhere to the facts. Spherics from NASA observing the mission from August 7th to the 15th proved to be rich in carbon dioxide plume rather than water, as with most comets, hinting at a drier, rockier composition from a distant system's outer edges.